on the first slide. We're going to fill in each blank and making sure that we understand that each problem is separate from the previous problem. So the first one is going to give us angle 1 and angle 8. So when we look over at the line, we are going to go ahead and look at how angle 1 and angle 8 are related. Then we're going to give it one of our 4 names, our 4 options being alternate interior, alternate exterior, corresponding, and then we're going to bring back that consecutive interior that we haven't done for a while. So those are our 4 options. 1 and 8, because they are on the outside of my 2 parallel lines, they're going to be our only exterior pair. So that is alternate exterior angles. No theorem, and actually we don't even need the A because the word angles is back here. So we really just need the alternate and the exterior, and then angles shows up at the end of the line there. And what do I know about alternate exterior? I know that those are equal to each other. So I'm just going to take my 115 and say that angle 8 should also be 115. Okay, now we have to forget everything we just said, everything we just thought about, and completely look at a new set of lines, a new set of angles as we do 7 and 6. Okay, so if this was a brand new piece of paper, 7 and 6. 7 and 6 are in between my 2 parallel lines, so they are interior. And because there is nothing in between them, 6 being right here, 7 being right here, those are going to be consecutive interior angles. So consecutive interior angles. Now those angles do add up to 180 degrees. It's the only pair that is supplementary or adds to 180. So I'm going to take 180 degrees and subtract 53 to get my answer for angle 6. Okay? Which is 127. There we go. There's your first set. Now there are going to be 4 of those on the test, so let's practice 2 more. I'm going to slide to the right. And let's look at the next 2, or the last 2. Let's go 6 and 8. It looks like angle 6 and angle 8. So 6 is right here. Angle 8 is right here. They are in between the 2 parallel lines, and they do alternate which side of the line that they are on. So those would be alternate interior. And I don't have to put angles because the word is there. And it looks like it says 85 degrees, so alternate interiors are also equal to each other, so I'm just going to copy that 85. Now if you're practicing on your homework or the formative assessment review, if you haven't done that one either, the formative assessment review did have questions where in here you could also have vertical or linear pair. So those are options, but they're not options at the top because those are just questions that are brand new to us. So the last one should be corresponding, but let's check it out just to be sure. So corresponding angles are in the same spot. So my first one is angle 2, okay, which is to the left of the orange line and is underneath this black line. And 8, which is also to the left of its orange line and underneath the black transversal line. So those are corresponding. So corresponding angles, and we don't have to put postulate because we're just putting what type of angles they are. And I know that corresponding angles are equal to each other, so I'll put that 73 right there. Okay, so we have gotten a level 1. We have to have all of those words down in our brains, and we also have to make sure this is the one word that we might forget to add on this interior piece as well. Okay? All right. Level 2. Level 2 now says, okay, let's kick it up a notch, and let's actually add in some algebra here. So we're going to find the value of each variable. We're going to justify the solution with the appropriate postulate theorem. So we do have to have, when we put the theorem or the postulate back here, if it's corresponding, we have to write corresponding angles postulate. If it's alternate interior, we're going to write alternate interior angles theorem. We're going to write that word in. So these two are located in the same spot along my parallel lines. So these guys, just like the last one we did, are corresponding. So I'm going to use the corresponding angles postulate to set these equal. The postulate tells me that I can indeed set them equal. So I'm going to take 4x plus 32 and set that equal to 172. Not too bad. Okay, we'll subtract 32 from both sides, so minus 32, which is 140. So 4x equals 140. Divide by 4, which is 35. Okay, and that is your level 2, almost. So your level 2 will have more than just one question, so just the one is great, but let's add in another one just to make sure that we feel confident about this. So let's slide it over, and let's talk this pair. They're almost touching each other, right? This 3x plus 16 and this 118. So those are right next to each other. And anything that's right next to each other, not across from each other, not on the opposite side of the line, right next to each other on the same line, those are going to add to 180. So even if you don't know the name, if you can get the x values right, you can still bump up to like a level 2 or a 2.5 if you can get some of the names right. So 3x plus 16 plus my 118, that's going to be 180. I'll combine like terms, which is 134. So I've got 46 when I subtract that. Okay, and this does not come out pretty, but that's okay. So when I finish this one up, x equals 15.3 repeated, or 115 and 1/3. So you can write 3 repeated, or you can write 15 and 1/3. And then what kind of angles are these? So if you're not comfortable with the words, hopefully you are, because 1 through 4, you have to do that in order to get a 1. But the algebra behind it, if you're not necessarily comfortable with this, you can still get points if you just get the algebra part right. These are consecutive, so we're going to do the whole shebang. Consecutive interior angles theorem. That's a mouthful. Okay, let's kick it up a notch a little bit. That's your level 1, your level 2. But let's see when there's multiple variables within the same problem, because that's also going to show up. So I'm going to turn the page here. We should feel comfortable on the front. That's a 1, 1.5, maybe almost a 2. I'll zoom in here for this question so we can really see what numbers there are. Okay, so I have an x and a y. So pick one. Pick if you want to do your x first or your y first. This one, it actually doesn't matter. So let's say we do x first. So you have to kind of see how does x compare to the number 109? Okay, so let's start there. How does x compare to 109? Are they equal, or do they add to 180? And the answer is they're equal. They're equal because they're alternate exterior angles. Okay, so we're going to go 5x minus 7 equals 109, and we're going to solve that. Add 7 and divide by 5. Okay, so when I add 7, I get 5x is equal to 116, divide by 5, and I get 23.2. That's my x value. Now those were alternate exterior angles, and I'm going to put theorem behind that, just to be clear. Okay, now what about y? So there are times when it's going to be important for you to plug x back in, or to plug the first thing you find back in. That is not this problem. We actually don't have to do that because, and you should always check and see, does this y portion have anything to do with 109? Are they related at all? And the answer is, again, yes, they are. They're corresponding. And if they're corresponding, that means I can set them equal. So we'll finish up the problem by just setting 8y plus 5 equal to 109 as well. Subtract 5, which is 104, and divide that by 8, which comes out to be 13. Okay, that really solidifies your level 2. Being able to do x and y with the same problem, but still only having one set of parallel lines. Now this particular problem, you did not have to plug x back in, you did not have to move anything, you didn't have to do anything special. They were kind of on their own related to 109. So the last question on this video, we'll go ahead and set up the x and the y, and we will plug it back in, and then the next video will get you the level 3 and 4 if you need or want help with that. Okay? Alright, so slide over here to this second one, number 6, slide 6 here. Okay, so here we don't have a number. So before I said relate the x to the number, relate the y to the number. And I don't actually have a number here. So instead, we're going to see how are my two binomials with x, with the letter x in them, how are they related? They're corresponding, so I'm going to set them equal. So we're going to take 8x minus 50 and set it equal to 3x plus 65. Okay, we'll subtract the 3x from both sides, which will give me 5x. We'll add 50. So 5x equals 115, and we'll divide, which is 23. Now those were corresponding. That part isn't the problem. It's now what do I do? How do I finish off with the y value? How do I find that y value? And the answer is, if you don't have something to relate y to, you need a number. You need something to relate it to, so you've got to figure that out. So what I'm going to do is I'm going to choose to plug this x value either back into here or here. It doesn't matter. If I plug it back into here, let's go 8 times 23, and then minus 50 is 134. So if I put a 134 here in my picture, I'm going to say 134 equals 15y plus 16, and call those alternate interior angles. I could also plug it back in here and use vertical angles. It just depends on where you put your 134 into the picture. So mine is here with the 8x, 134 equals 15y plus 16. So I'll take 134 and subtract, and then divide, which again gives me not a great number. And my justification will be, since I put it here in my picture,